Hello there, welcome to this presentation about the composition of functions. We will be looking at the composition of linear functions, composition of quadratic functions, the composition of piecewise defined functions, as well as finding the individual functions if you're already given the composite function. Okay, so to start us off, we will definitely start with a definition, as is the standard practice, so that we know what we are dealing with. Right, so definition of a composition of functions is as follows. If f and g are functions, the composite function of f and g is defined by f composite g, which is f composed of g, right? And that is basically the definition. Depending on how you read this, you can compose g with f, right? Or we can talk about g composed of f, right? So this is also a composite function, but it's g composed of f, and this is f composed of g. All right. So this takes care of the definition itself. I want us to just pick up two things from the two equations that we have indicated here on the board. F composed of g, we end up with f being what is called the outer function, and g is the inner function. Here, when you deal with g composite f, g is the outer function and f is the inner function. This may very well remind you of the chain rule, and actually at the end of this video there will be an end screen button that you can click on so that you link this presentation to the chain rule and see how they are connected. All right, so this takes care of the definition, and we are now going to go to our first example where we discuss the composition of linear functions. Let's go for it. All right, so here's the example. Given f of x is equal to 3x plus 1 and g of x is equal to 2x plus 4, find three compositions: f composite g, g composite f, and g composite g, or g composite of itself. Okay, so let's do that. We know that this is f composed of g, so we plug in g inside f, and this really means that the expression of g, 2x plus 4, right? Whenever we see x, we replace it with the expression of g, and the rest of the constants remain where they are. It's 3 times 2x plus 4 plus 1, right, is equal to 6x plus 12 plus 1, which is 6x plus 13. Okay, g composite f, and the g composite f is g x, the expression of f, 3x plus 1. So in g, whenever we see x, we replace it with the expression of f. So we go 2 is 3x plus 1 plus 4, and this is 6x plus 2 plus 4. Okay, and this will be 6x plus 6. So what do we pick up? The gradients are the same, but the y-intercepts are different. Okay, it's an observation. Let's go to g composed of g, and this is g. I'm going to plug in 2x plus 4 in g, so it's 2 times 2x plus 4 plus 4, giving us 4x plus 8 plus 4, which is 4x plus 12. Okay, so that is basically a straightforward approach to composition of functions. Well, basic types, the linear functions. Let us now go to quadratic functions. What happens when you compose a quadratic function with a linear function and vice versa. Let's go for it. Right, so here is example 2. Given g of x is equal to x squared and h of x is equal to 3x minus 1, find g composite h and h composite g. So let's do that. This is equal to g composed of h. Expression for h is 3x minus 1. So there's only one term here. It's obvious that we just need to substitute once. So we go 3x minus 1. What must we do? Square this. You can leave it like this, or you can simplify into 9x squared minus 6x plus 1. It's a quadratic function. So we plugged in a linear into a quadratic function, we end up with a quadratic function. This side, now we do the opposite. Okay, so this will be h composed of g, linear, composed of a quadratic. So we have x squared. So whenever we see x, we plug in the x squared. So this becomes 3x squared minus 1. So the linear now ends up being a quadratic function through the composition process. So this takes care of example 2. Again, straightforward. Okay, let's go to example 3 now, where we deal with piecewise defined functions. Alright, so here's example 3. We're given a linear function and a piecewise defined function. We are asked to find these two things. Let's start here. F composite g, or f composite g, right? G is a piecewise defined function, so we take g into f. So g comes with its restrictions. So wherever we see x, I'm going to plug in these expressions, right, and keep the restrictions. So the first one, x plus 2 in place of x plus 4 if x greater or equal to 0, right? So this becomes actually x plus 6 if x is greater or equal to 0. Okay, and then we take this one, x minus 2 now, plus 4 if x is less than 0. This becomes x plus 2 if x is less than 0. Good. Now we take the composition of g and f. So this is g composed of f. So what are we saying? In place of x here, wherever we see x in g, we're going to plug in the expression of f, including that x, right, the restrictions. So now we end up with the following. X plus 4 plus 2 is x plus 6 if x plus 4 is greater or equal to 0, which therefore means that x greater or equal to negative 4. Plug in x plus 4 here, you end up with x plus 2 if x is less than negative 4. Okay, so this is basically it for example 3. Right, so this is example 4, the last example in this presentation. Given capital letter f of x is equal to cos square x plus 7, find the functions f, g, and h such that the capital letter f of x is the composition of those three functions. Right, so we're doing the reverse of what we have been doing. We want the expression of f, expression of g, and expression of h. Well, there are many ways in which to approach this, and one way can be the following. Okay, we're taking h into g, and that composition we take it into f. Right. So basically that is what we need to have. This is a true x plus 7, it's a linear function. It went into cos, right, to give us cos x plus 7, and then we squared that. So basically this is what we have. X plus 7 going into cos x, and this now goes into x squared. Those are the three possibilities of this type of composition, and I challenge you to think of your own to come up with the very same function that we have here on the board. Okay, so this will be the end of the video. Thank you for watching and thank you for tuning in. I'll see you in the next set of the upcoming videos. Keep well.